In this video, we're going to develop our Pythagorean identities from our trigonometric identities. So we already have these identities, the reciprocal identities, cosecant 1 over sine, secant 1 over cosine, cotangent 1 over tangent, and then tangent sine over cosine, and so forth. And so we have three more identities that we're going to add to our fundamental trigonometric identity list. So again, let's go ahead and actually, we're just going to start off with the Pythagorean theorem. The Pythagorean theorem states that we have x squared plus y squared equals r squared. Okay, so now let's go ahead and develop this first identity, and to do that, we're going to multiply everything by 1 over r squared. So when we do that to both sides of the equation, we end up with x squared over r squared plus y squared over r squared equals r squared over r squared. Now r squared over r squared becomes 1. And let's go ahead and simplify these. So now, because we're taking two things that are being squared and dividing it, we can rewrite that to be x over r squared plus y over r squared equals 1. Now, to complete this identity, the next thing we need to do is make an observation. Now remember, x over r, that's the same as the cosine. So let me write that over here. The cosine of theta, we said, was x over r. So we're going to substitute in cosine of theta in here. We also know that the sine of theta is y over r. So let's substitute in the sine of theta here. And so we're going to end up with a cosine of theta squared plus a sine of theta squared equals 1. All right, so we're almost done. This is basically the identity right here, but we do write it a little differently. One thing to keep in mind is that when I have, say, the cosine of theta squared, we can rewrite this to be the cosine squared of theta. So these are equal. So if you ever see cosine squared of theta, that means the whole cosine is being squared. And the same thing with the sine. So we're going to have the cosine squared of theta plus the sine squared of theta equals 1. And then we switch these and we end up with the sine squared of theta plus the cosine squared of theta equals 1. And there is our first Pythagorean identity. So let's write that out in our little list here. Our Pythagorean identity. And the Pythagorean identities start us off with the sine squared of theta plus the cosine squared of theta equals 1. Okay, so there's two more of these. Maybe I'm going to put a box around that one. That's pretty important. There are two more of these. And the first one is we take the sine squared of theta plus the cosine squared of theta equals 1. And we're going to multiply everything by 1 over the cosine squared of theta. So when we distribute this 1 over cosine squared of theta, we're going to have the sine squared of theta over the cosine squared of theta plus the cosine squared of theta over the cosine squared of theta equals 1 over the cosine squared of theta. Okay, so this one's easy enough. Cosine squared over cosine squared is just 1. But now we have to look at these two. Now, if you remember, the tangent of theta is the sine of theta over the cosine of theta. So if we go back to our fundamental identities, sine over cosine is tangent. So if that is true, we can replace sine squared over cosine squared with the tangent squared of theta. And then 1 over cosine, well, we should remember that there's a fundamental identity about that. 1 over cosine is the secant. So that means the secant of theta is 1 over the cosine of theta, and so that's where this goes. The secant squared of theta. And so for this one, we end up with the tangent squared of theta plus 1 equals the secant squared of theta. And that is our next Pythagorean identity. I'm going to put it over here. The tangent squared of theta plus 1 equals the secant squared of theta. All right, let's do one more. And that has to do with going back to sine squared plus cosine squared. And this time, instead of multiplying everything by 1 over cosine squared, we're going to multiply everything by 1 over sine squared. And so we're going to have the sine squared of theta over the sine squared of theta plus the cosine squared of theta over the sine squared of theta is 1 over the sine squared of theta. This becomes 1. Cosine over sine. Well, if we go back to our identities, we realize that cosine over sine is the cotangent. So why don't we put in the cotangent squared of theta? And then 1 over sine, let's see here, 1 over sine is cosecant. So this equals, this for here, we're going to put in the cosecant squared of theta. So let me write that over here. The cotangent of theta is the cosine of theta over the sine of theta, and the cosecant of theta is 1 over the sine of theta. And so we're going to end up with 1 plus the cotangent squared of theta equals the cosecant squared of theta. And that is our final Pythagorean identity. 1 plus the cotangent squared of theta equals the cosecant squared of theta. Okay, now we're going to use these identities here pretty soon, but one thing that I think I need to clarify is when it comes to Pythagorean identities, the only one I remember is sine squared of theta plus cosine squared of theta equals 1. That's the only one that's in my brain. If I need these other two, I don't remember these. What I remember is how to rederive them. So, for example, if I know I need tangent, I think, well, I'm going to have to multiply by 1 over cosine squared of theta through and rederive this. Or 1 over sine squared of theta. I'm going to multiply that, and I get this identity. So, kind of keep in mind that we don't memorize these two. We only know this one, and then it's easy enough to rederive the other two.